Hello everybody, as I promised you in this lesson we want to learn how to balance chemical equations. So without saying too much introduction, I'm gonna directly go to that. I first start with a simple reaction and I will write everything with the red, I'm sorry. Consider this equation after burning. This equation actually shows when hydrogen gas burns in air which contains oxygen to produce water. As you can see, this equation is not balanced because the number of atoms in the reactants are not equal with the atoms to the products. So for balancing, first write everything for yourself in the reactants and products. So I will write what I have in the left side of the reaction, hydrogen, oxygen, and in the left side, of course, I have the hydrogen and oxygen. So the number of hydrogen in the left sides are 2 and in the right sides they are again 2. So it seems that they are balanced. But for the oxygen we have 2 here and 1 here. So they seems that they are not balanced. What will happen? Okay, if I add the 2 at the right side, number 2, so it seems that now the number of the oxygens are balanced. So if I write it again, hydrogen, oxygen, hydrogen, oxygen. For the oxygen, it seems that they are balanced. Okay, but what about the hydrogen? Are they balanced too? Okay, we have 2 in the left side in the reactants and we have 4 in the product, so they are not balanced. So what should I do? I should add another number here to the left. So the final reaction which is balanced is 2 molecular hydrogen plus 1 molecular oxygen gives us 2 molecule of water. That is the balanced equation. Okay, let's move on the other example, maybe which is a bit difficult. I don't know. For balancing this equation again, we use the same strategy. Write everything for yourself on the left side of the reaction and on the right side of the reaction. What we have? Potassium, chlorine, and oxygen, and exactly the same thing at the right. So for potassium everything seems normal, so it seems it is balanced. For chlorine as well, but the problem is related to oxygen. Something doesn't go well. For oxygen on the left side we have 3, while for the right side we have a molecule of oxygen and we have 2. So what should we do? Okay, let's think. If I consider 3 here and 2 here, so I've got the oxygen in balance. Now we have 6 oxygen atoms here, but the thing that has been changed is related to potassium and chlorine, that we have 2 of them on the left and 1 on the right, 1 of each on the right. So the balance equation would be obtained if I have a number 2 here. So I will write everything from the beginning to be sure if all of them are balanced. Again, for the left side I have potassium, chlorine, and oxygen, and for the right side I have the same elements. Consider potassium left 2 and right 2, chlorine 2, again 2. For oxygen I have 6 and 6. For both sides, everything's are balanced. So this equation is balanced. Okay, that was, okay, if I add here 2, that was the same one, and I wrote it 2 times, no problem. Let's solve another example. The combustion of the natural gas component ethane in oxygen, which gives us these products. We need to balance it because it seems that it's not balanced. Well, I will write all the elements that we have for the left and right side. For the left, I have carbon, hydrogen, and oxygen. And for the right side, everything, carbon, hydrogen, and oxygen. For the left side, for carbon, we have 2, while for the right side, we have 1. So it's not balanced. For hydrogen, we have 6, while here we have 2. Again, it's not balanced. For the oxygen instead, wow, nothing is balanced for this equation. 2, 3. So, what do you think if I start from which element to balance? Okay, since I prefer always the easiest way, I prefer carbon to balance first. Okay, if I add 2 here, it seems that I have balanced carbon, but something doesn't go well again because the number of oxygen would be changed. How many oxygen we have now? Well, okay, better not to show it first because it's a bit confusing. I will write again here. For left side, carbon, hydrogen, and oxygen. For the right side, we have, I will write here R left, L, and R in order to avoid writing again. Carbon, hydrogen, and oxygen. Okay, for the left side, 2, 2 of carbon. It seems that we were successful to balance it. For the hydrogen, still it needs to be balanced. 6, 2. Again, it's not balanced. And for the oxygen, we have 2 and 4. Okay, so what do you think? I prefer, because in the previous solving I didn't balance hydrogen, so now I prefer to balance it as well. For the hydrogen, 6 and 2. So if I add 3 here, it seems that I have balanced hydrogen as well. So I will write 6 here. So it seems that I have balanced it. But for the oxygen, still we faced imbalance. So in the new equation, since for oxygen we have 2 here and 7 here for the oxygen, as you can see, the number of oxygens here are 7 and here are 2. So 1 molecule of oxygen. So if I add the 7 to the left side, it means that now I have 7 atomic oxygen here and 7 atomic oxygen here. But you know that all the numbers in a balanced equation should be whole numbers. So what should I have to eliminate this ratio? It means that if I multiply all the equation by 2, so I can eliminate this ratio. It would be, the final result would be like that. 2 ethane after burning with 7 oxygen, it gives us 4 carbon dioxide molecules and 6 molecules of water. So the final one is the balanced equation, as you can see. Now let's solve another example, which is like a question. When aluminum metal is exposed to air, a protective layer of aluminum oxide forms on its surface. Write a balance equation for the formation of aluminum oxide. Fair. Okay, I will first write an equation, not balanced one. From the practice, from this question, I can extract. When aluminum reacts with oxygen, molecule oxygen, we can have the oxide of aluminum, which is called aluminum oxide, Al2O3. This equation, of course, is not balanced, so I have to balance it, of course, by the same method that I tell you, left and right. In the left side of the reaction, I have aluminum and oxygen, and in the right side as well, aluminum and oxygen. Okay, in the left side, 1 aluminum, 2 aluminum. No, it's not balanced. And in the right side, again, for oxygen, in the left side, 2 and 3, which is not balanced. Well, what should I have to do? First, I will try to balance aluminum, and then I will see what will happen for the oxygen. Okay. If I add 2 here, it seems that I have balanced aluminum, but oxygen still needs to be balanced. So 3 oxygen, atomic oxygen here, while we have 1. So if I add 3 seconds, it seems that now the equation is balanced, but we need to have a whole number. So I will multiply all the equation by 2 to find the balanced equation. So better to write it with black. 4 aluminum after exposure with 3 molecular oxygen gives us 2 molecules of aluminum oxide. That is your balanced equation. Well, the last one, maybe it is a bit challenging. Let's go inside of this example. Balance the equation representing the reaction between iron trioxide, Fe2O3, and carbon monoxide to yield iron and carbon dioxide. First, write the equation only, without nothing. I will write it here. Fe2O3 after reaction with carbon monoxide gives carbon dioxide plus iron. Okay, now I will prefer to write all the elements that I have from left to right. Let's do this. Iron, oxygen, and carbon. Now here in the right, iron, oxygen, and carbon. The left side we have 2 iron, and in the right side 1, so it's not balanced. Regarding the oxygen, we have, well, 4, and in the left side how many? 2, and again it's not balanced. The condition is only fine for carbon. 1 carbon, 1 carbon, so it is the only thing which is balanced. So what do you mean if I start from iron or oxygen for balancing the first? I don't know, it depends on you. Iron is easier because here is single without nothing. So if you balance it, it seems that it won't change anything. So since I have 2 here and it is more, I will add a 2 here. So I didn't change any other things. But regarding the oxygen, oxygen in the left side is 4, while in the right side it is 2. So it seems that if I add a number 2 here, I have balanced oxygen, but at the same time I have changed the number of carbons. Now we have 1 carbon here at the left side, while 2 at the right side. So it's not any more balanced, while oxygen now it is balanced. I will write the new numbers. Now I have to make a good decision. Let's think. In the new equation that I have here, I will write all the atoms again, because maybe if I don't write them, I would be a bit confused. Well, from iron, oxygen and carbon, iron, oxygen and carbon, I have 2 oxygen here, 4 here, 4 carbon, 1 carbon, 2. They are the same as the right that I wrote. So I made this decision. I will write this equation again with changes here a bit. Fe2O3 plus carbon monoxide, which gives us CO2 plus 2 iron. If I change this number to 3 for both of them, let's see what will happen. Iron remains the same. Oxygen, how many? 6 here, and here 6. While carbon, 3 at the left side and 3 at the right side. So all the atoms are balanced, and the final equation is also balanced. At the end of this lesson, in descriptions, I will upload you a PDF file containing different examples along with solutions for practice. Have a good day. See you in next lesson.